Hello everyone, welcome to another episode of Math and Silly Hats. Today we're going to be dealing with fractional exponents. Let's get into it. Let's say we have something simple like x to the 2/3. We have a fractional exponent. Well, x to the 2 would be really easy, it would just be x squared, right? But then we have to deal with that denominator of 3. Alright, so let me highlight some things. Numerators are green, they make us happy, because x to the 2 would just be x squared. That would be nice. But we have this denominator, divided by 3. Those make us sad. They make things smaller generally. So how this is going to work out is we still have x here. It's going to get taken to the second power. Seems simple enough. But then we're going to have to make it smaller. We're going to take it to a root, and the root we're going to take it to is going to be whatever that denominator was. In this case, 3. So this is going to be x squared, but we need to take the third root of that because we're taking it to a fractional exponent. Crazy, right? Get deeper down the rabbit hole we go. Well, I'm going to call this an easy problem. It may not seem easy. Say we have x to the 4th, y to the 2, all of that taken to the 3/2. Okay, so this exponent is going to act on everything individually, and as we kind of covered, this works kind of like distribution, where we're going to be distributing this 3/2 to both of these. So let's do that one at a time. Again, we need to remember we're going to take each of these factors to the numerator's power, but then we need to take them to the denominator's root. So this factor x is going to be x to the 4th, just as it was, but that's going to go to the third power. And then all of that is going to be taken to the second root, or just a normal square root. So what does that mean? Well, we've got simplified x to the, when we take the power of a power, we multiply the two exponents. So it's going to be x to the 4 times 3, or x to the 12th power. But then we still have to deal with this square root of. So as an aside, we're trying to figure out what the square root of x to the 12th is. Now, the square root of something just means we're looking for something that when multiplied by itself gives us x to the 12th. We're going to kind of think backwards to the product rule. When we multiply two things together, we add their exponents. So x to the 6th times x to the 6th would be x to the 12th. Thus, the square root of x to the 12th is just x to the 6th. So we've covered the left half. Now the right half, we had y squared taken to the third power. Then we need to take the square root of that because of the denominator of 2. So let's simplify inside that square root first. Y to the 2 times y to the 3 will be y to the 2 times 3, power of a power rule. So we need to find the square root of y to the 6th. Again, we can kind of think of this backwards. We can say, well, anything square root is just something times itself that gives us that. So y to the something times y to the something is y to the 6th. Well, we need two things that would add together to give us 6. So y to the 3 times y to the 3 would be y to the 6th. So the square root of y to the 6th is just y to the 3. Mr. B, you said that would be easy. It's kind of easy. It's relatively easy. Sometimes things don't work out so nice. Let's do another one. Let's do a difficult one. So let's say we had x to the 4, y to the 8, z to the 3. All of that taken to the 2/3 power. As remember, numerators make things bigger, denominators make things smaller, and this power is going to be working on each of these individual components. That's going to get kind of distributed to all of these factors, the x's, the y's, and the z's. Let's do the x's first. So x to the 4th gets taken to the second power. So x to the 4th squared. But then we need to find the cube root of that from the denominator. So the numerator made our factor, x to the 4th, larger. But then our denominator, this 3, is going to have to take the third root of whatever that is. Power of power rule, x to the 4th to the second power is just going to be x to the 4 times 2. And then we'll take the third root of that. Now, can we simplify that? So the third root means we need something that when we multiplied it by itself, by itself, by itself, would be x to the 8. So is there something that we could multiply by itself 3 times that would give us x to the 8? Well, x to the 2 times 2 times 2 would only be x to the 6th, right? So that won't work. X to the 3 times 3 times 3 would be x to the 9th, so that won't work. So this one is not going to have a variable to an integer solution. So this will just stay the cube root of x to the 8th. Let's deal with our y's. Y to the 8th taken to the second power from our numerator, and then we're finding the cube root of that. So y to the 8 squared is going to be y to the 8 times 2. So y to the 8 times 2. So 8 times 2 is 16. Y to the 16th. We need to find the cube root of that. Again, is there something that when we multiply it by itself, by itself, by itself, we get to the 16th? Y to the 5 times y to the 5 times y to the 5 would be y to the 15th. That ain't gonna work. No, this is going to remain as it is. Y to the 16 cube root. Now, if all of this is in the cube root, not a whole lot will change. We'll just combine all of the factors that are within these cube root symbols and then take the whole thing to the third root. But let's see if we can simplify the z's. So we had z to the third. That's going to be taken to the second power. And we need to find the cube root of that. So z to the third squared is going to be z to the 3 times 2. We need to take the cube root of that. Z to the 6th cube root. Is there something that when multiplied by itself times itself times itself would be z to the 6th? Well, z squared times z squared times z squared would be z to the 6th. So we can take the cube root of this. It's just going to be z squared. So our final solution is this mess right here. X to the 8 cube root, y to the 16th cube root, and then just z squared. So sometimes things work out nicely and we can simplify down a bit.
Sometimes things don't work out so nice.
Is that crazy and convoluted enough for you? What? This has been our first look at the fractional exponent law. Let's see how this goes. Leave comments, questions, suggestions for a deeper explanation or maybe some more appropriate examples or some real-life problems you've been assigned about this law in the comments if you'd like to see me cover more of it. Have a great day, everybody. Bye-bye!